Today, inshallah, we will talk in this video about volumes by cylindrical shells. As I see here in the left side, I have a function f of x greater than 0, and I have a closed interval from a to b. Also, I have a region R bounded by f of x, bounded by the function f of x, and x-axis on the closed interval from a to b. What we need now? We want to make revolving about this region R around y-axis. In this region, I will take a rectangle as I see here in this picture. This rectangle here with thickness delta x, which is xi minus xi minus 1. So here, this is the thickness or the width of this rectangle. It's delta x. So I have here a point. I want to make revolving around y-axis, so I must focus on this distance. After that, I will make the revolving for the point. It's coming like this. If I ask you now, what is the shape you have? The answer is, I have a cylinder. This cylinder coming from revolving for the rectangle. But this rectangle with thickness. So my cylinder here will be with thickness, with small thickness, delta x. This rectangle gives me this cylindrical shell. Now, the question is, how many cylindrical shells can I have from this region? The answer is, I have infinitely many cylindrical shells. Because again, I can take another one, for example, like this. If I take a point here, for example, I will find this cylinder. As you see here. So finally, if you take all your rectangles, you will find this shape, this solid. Now let me focus about this shell, the first one. This cylindrical shell. We have two things. The first one is the radius. So I have a radius r. Also, I have a height, which is h. How can we talk about r and h from this graph? R, it's the value from here to here. It's coming here. This one. So this is the r. Now, what's the value of r? The value of r it's the same value of x, so I can write r equal x. What about h? H, it's this value, this distance. This distance is the value of f of x, because here you have a point x give you the value of f of x, which make the height for this cylinder. So h equal f of x and r equal x. But as we told you before, we must have a lot of cylindrical shells. I will represent x as ci and f of x, which means h, as f c of I. As generalization for this case. Now I will take this cylindrical shell down to look with you what is the components for this cylindrical shell. As I told you before, I have R, which is Ci, and I have H, okay, which is F of Ci. If I take this cylindrical shell with thickness delta X and open it as a rectangle, as you see here, I have three things. The thickness, delta X, and the length, which is the circumference of cylindrical shell, which is 2 pi r. That means 2 pi ci. Also, I have a height, which is h, it's f of ci. What about the volume for this cylinder? The volume is 2 pi r, 2 pi ci, times delta x times h, length, width, and height. Length, width, and the height. So the volume of this cylinder is 2 pi ci times delta x times h. Now I will make summation for all volumes for these cylindrical shells. It's coming like this. 2 pi ci, f of ci, it's h, because h, it's f of ci. So 2 pi ci, f of ci, delta x. Summation from I equal 1 to n, because I have infinitely cylindrical shells here. When you take the limit as in goes to infinity, that means you will have the finite integral from a to b. For what? For 2 pi x f of x dx, because now all ci here will be x. Ci in the definite integral, I will put it as x. So the volume depends on the cylindrical shells is a definite integral from a to b 2 pi x f of x dx. 2 pi x it's the radius, f of x is the height, and dx is the thickness. So when we ask you about find the volume using cylindrical shell revolving around y-axis, you must use this definition. Next video, inshallah, we will have an example to explain for you how can we use this law. Goodbye.